go. Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your ever-present host of the Db2 Night Show, and today we have a first-time, very special guest with us, Calisto Zuzarte of the IBM Toronto Lab. He's the learning optimizer man, so we wanted to hear from Calisto today. How are you doing, Calisto?
I'm good, thanks, Martin.
Oh, great. Okay. As everybody says, they're great. We're Canadians. We're always great. It's a wonderful sunny day, and it's going to be nice and warm. Let's move along. I'm afraid one of these not-so-silent hosts of the Db2 Night Show has showed up for liver treats. At first, I thought it was a good thing to have them be quiet, but now they come in and beg for them, even when you don't want them to. But moving along, here's our social media things, our hashtag of Db2Night on Twitter, and our replays are now available on YouTube. I announced the shows on Twitter as well as on Db2 list server, and I also announce when the replays are available, and that'll be later this afternoon. Here's our disclaimers. Basically, everything's recorded. We respect people's copyrights, and anything you say will be recorded on the night show. So there you go. Quick announcements. Well, we got the announcements always get short at this time of year because we're coming into our summer break. So our advice is to go back and see any shows that you missed. There's now 14 seasons of replays available. The newer ones are available on YouTube as well. That makes it a little easier because we have a YouTube channel. And as always, our founding sponsor of the Db2 Night Show is DBI Software. We thank them for the use of the hall, so to speak. And we also like to remind people that they have Db2 LUW performance tools available, and you can see those on their website at dbisoftware.com. And DBI also now supports SQL Server. Congrats to our winner of last show was James Neary of Manulife. He's going to get an Amazon gift certificate. Congratulations, James. And our sponsors are DBI Software and yours truly, Martin Hubel Consulting. And now we're into the polls. Unfortunately, we didn't have time to really update these, but I think we'll be able to make do with the ones we have because they're, we'll be able to do some of these polls now. And we're currently distributing the poll. We should be able to vote on that shortly. And as always, we seem to have a wide range of people running various versions of Db2. Some of the older people are so dependent upon it, they have trouble updating. Other people are dependent upon their vendors, and other people try to be as close to current as possible. So we'll close that and share the results. And there we see that over 50% of our audience is now on a newer version of Db2, 11.5.6 or higher. We'll hide that and move on to our next question. Actually, a lot of these seem to apply to today's show as well. What explain tools are people using? And it's always interesting to see this. People have voted pretty quickly, so I'm not going to hang around on that. And what we see is people are still using the command line explains the most. I'd fall into that category myself. We have data management console or some other equivalent IBM tool, and then vendor tools where we don't use explain. Okay. Next one, what do we have here? Do you have automatic run stats enabled? And what we see there is Some people trust it completely, and that's great. Other people have it on some databases, and other people are saying no. That might be that you're an older customer that have good scripts that work, so you don't really need to have anything else. Use optimization profiles. And we've got people voting quickly, and what we see there is 29% of the people say yes, 71% say no. And that was actually from John's presentation earlier, so people know what they are. And have you tried the machine learning optimizer? And here's why we wanted you on the show, Calisto. Out of our audience, we see that 25% of our audience is not yet but planning, and the other 75% say no. So we need to do some information sharing to get people up to speed on that. And with that, that's the end of our polls. I'll put that back over here. And now I guess I've got a summer cartoon here, seeing as we're getting into summer. I don't know why this is summer, but it's a pig at the seashore. I really don't know what that image portrays, but it seemed to be a thought-provoking, humorous image for the what we might all be doing this summer. Like this pig, I used to be a lot thinner. So with that in mind, Calisto, we'll turn things over to you. As with the DB2 night show, there is a question and answer tool where people write in their questions. And as they do that, I'll read them to you at a convenient point in the show to make things a little interactive. So let me manage that for you. And so please take it away. You're all set. We see your screen. You're on the DB2 Night Show Machine Learning Optimizer feature, and you're all in black, and we'll take it from there. In the meantime, I'll mute my mic in case there's a dog that goes by in the street.
Thank you, Martin.
Thank you.
So based on that poll, I think by the end of this presentation, hopefully we'll see a lot of you say, yes, we have tried it, because I really would like some feedback on the tech preview, which is available right now. So I'm going to talk about not only the tech preview, but also I'll talk about what we have in plan for production. And the tech preview is basically intended only for your test systems. When we GA in our next version, and I'll tell you why we are waiting for the next version to GA, then you will be able to enable it for your production systems. So let's start with a little bit of motivation, some background as well. So this must be a familiar term with most of you, but artificial intelligence is essentially the simulation of human intelligence in machines, which are programmed to think like humans. Machine learning is one method to provide these AI systems the ability to automatically learn and improve from experience without being explicitly programmed. And that's the key difference why we are infusing machine learning in the optimizer. We've had the traditional optimizer that we've been working on for the last 30 plus years. And there are many of us in this organization who work on the optimizer. And it is a lot of effort put into maintaining the features. Every new feature that we add in DB2, we have to tweak the optimizer. So it's a continuous and very arduous task to develop an optimizer. And machine learning will help us tremendously there. There are many different machine learning algorithms. The one that we've chosen is the neural network, but it's not going to be limited to just a neural network. We've chosen that for various reasons, but essentially what a neural network is it's just a series of algorithms that tries to recognize relationships in a set of data. And it does this by using interconnected nodes, just like the neurons in the human brain. I'll talk a little bit more about how the neural networks in a later slide. So essentially, artificial intelligence is this whole system. Within that, there are various types of machine learning algorithms. One of them is using neural nets, and those are the ones that we incorporate in the current version of what we are infusing machine learning in the optimizer form. Some background on the challenges. I briefly mentioned, 30 years, many people, hundreds of person years worth of effort. And it's all coded in C++, And as we do this, there are lots of simplifying assumptions that are built into this optimizer model. Assumptions like, for example, with default statistics, we collect statistics on each column and we treat each column separately. So if you have two predicates on different columns, we don't understand the relationship of the data within these two columns, whether they're correlated or not. So for that, we need some advanced statistics, and it's always a big tuning effort to tweak and tune queries that have performance issues. I already talked about the optimizer development effort, and that's a big reason why we have embarked on this journey of infusing AI in DB2. So what are the benefits of machine learning? For one thing, it's adaptable to very specific customer data. It's adaptable to the workload, the specific customer workload. May not be in the initial phase of what we are putting into DB2, but eventually with a solid feedback mechanism, we will be able to learn the query patterns, the use of, which columns are used in predicates, as well as eventually for any other future machine learning needs. We'll learn the environment, how many DPF nodes are there and what do we need to take into account with the buffer pool sizes being what they are and things like that. It also can exploit both the optimizer as well as runtime feedback to learn specifics of the customer workload data and behavior. So when we started this whole effort, and it's been a long time, we started it sometime in 2013. A colleague of mine, Vincent Corvinelli, and I, said, let's look at this new thing that is being quite popularly talked about on the internet, and let's see what we can do to infuse that in the optimizer. So we said one of the goals is to automate everything. We don't want to have the user worry about tuning and tweaking the machine learning model to make the query performance stable. We want to achieve reliable performance automatically, and we want to simplify optimizer development. And one of the key ways of doing that is not by a rip and replace type of exercise where we throw off the the existing optimizer and put a completely brand new machine learning optimizer. We want to infuse it gradually. We have customers, we have to do it in stages. It would take us a long time to get it perfect. It's already taken us 30 years and the current optimizer is still not perfect, even if I have to say so myself. So when I say infuse AI gradually, what do I mean? So we are going to start off with cardinality estimation. Essentially, cardinality estimation is estimating the number of rows that flow in and out of an operator. And so, for example, you have a table scan, you have some predicates applied there. You might have 7 million rows in the table. After applying the predicates, we estimate that 250 rows are going to flow out of that operator. So that estimation is what we term as cardinality estimation. So we're going to start off with cardinality estimation for common local predicates. And when I say common local predicates, I mean of the form column equals or greater than, less than some constant. Eventually, there will be other things that we will need to take care of. For example, parameter markers, predicates with expressions on them, cardinality after a group by, for example, and also joint cardinality. So the first phase, we focused on local predicates, but we are currently working on the joint cardinality estimation. I'll tell you in advance, in the tech preview, we do have a very preliminary version of the joint cardinality estimation, but it's very limited. And we're working on solidifying that aspect of it. And hopefully we'll have something much better in our GA version. We'll also look at joint planning in terms of joint order, joint types, and other aspects. We've got a lot of activity that is going on for accounting for other things within the optimizer. So why did we start with cardinality estimation? If you look at the customer performance related issues that we've got over the last few years, we did some analysis and we found that about 60% of the problems that were reported by customers are related to improper or inaccurate cardinality estimation. So that's where we said we need to focus on first, because if we can address a good portion of those performance problems with our machine learning optimizer, then so much the better. Cardinality estimation is very critical for cost-based optimizers. So our traditional optimizer essentially has the operation costs calibrated as a per row cost. So for example, if we are doing a scan operator, every row that goes through the scan operator has a particular cost, and we calibrate this cost as a per row cost, and with the estimated cardinality, we can get the cost of the entire operation. And that allows us to distinguish between various types of plans and subplans, and eliminate the expensive ones and keep the ones which are very optimal. So here's an example. I have 3 snippets of this 3-table join. If you look on the left-hand side, that's the plan and the estimate, which is highlighted in yellow for when we use the default statistics. So no column group statistics, no statistical views, just the basic individual column statistics and the table statistics. So you can see that the estimate at the top of the query is about 1,000 rows. And the actual, which is shown at the top, and let me see if I can get my pointer here. If you look at the actual estimate, the actual cardinality, it's about 10 million rows. And we only estimated 1,136 rows. And if you examine it a little deeper, you can see that this table scan, the estimate is 0.2 rows or 0.28 rows. And that seems odd. It's really a probability of getting a row, but it is where part of the problem is. And we noticed that there were multiple predicates applied on this scan, and the columns involved in those predicates were strongly correlated on the date dimension table. So by collecting column group statistics on those columns, we were able to capture the statistical correlation between those columns and get a more reasonable estimate of 116 rows. So this must have been something like 4 months of data. But if you look at the top of the plan, we still have about 500,000 rows, and that's about 20x of the actual. So we examined the join, and we found that there was some skew in the join, or not really skew, but more of an overloaded dimension, where the date dimension had 200 years worth of dates in the dimension table, but the fact table had only about 5 or 6 years worth of data. So by defining a statistical view, we were able to correct that and get around 9 million rows, which is fairly close to the actual cardinality. And you can see that the plan flipped here, and we got much better performance with both the column group statistics and the statistical views. So this essentially tells you that there is a tuning effort required to capture these correlations and skew in the joint predicates and the overloaded dimensions. And that's what we want to have our machine learning feature capture automatically. Okay. So if you really want a little more information, you can look at this very early paper that we had, and we've changed the algorithms, we've changed some of the things that we've did since that paper, and we've improved it. But you can see here that Vincent and I are from IBM, and the other 3 authors here are very, very bright students that we got in 2013 when we started this project. So down below you can see some kind of a diagram which shows a neural network. So essentially we have these nodes in the network, and we have different layers. So in this example, this is a very simple neural network with 3 layers. We have the input layer, we have a hidden layer, and we have the output layer. This is a fully connected neural network, and we store some information on these edges that connect the various nodes. And that information is some kind of a weight information that allows us to do this prediction. So we encode the data that is input into this neural network. So for example, if we have predicate data and we're trying to estimate the cardinality based on applying those predicates to the table, we will have some table information in terms of the number of rows. We will have the predicate information in terms of which column is the predicate is on, what is the operator type, and what are the constants. And we use a sample of data to estimate the selectivity of these predicates And we feed, as part of the training, we feed the output of the actual estimate based on that sample. It's not an actual estimate for the whole table, but it's on that sample. But it gives us an idea of what percentage of the rows will be selected. So now once we have all the input necessary and we feed this in through the neural network, it looks at the weights and it comes up with a prediction of what the estimate is. Now we compare that with what we are training it with, and based on the difference there, we will go back and adjust all the weights in the network. That's what is termed as the back propagation. So eventually, after feeding, millions of queries or hundreds of thousands of queries, we will come up with suitable weights that connect the different nodes in the network. And now, eventually, when we want to predict the cardinality, we give the input pretty much the same way as we train the network, and it will look at the weights and it will come up with what is the predicted estimate. Okay. So let's look at the tech preview. I've got a link here. This is what the latest documentation is. You'll notice that it is on 11.5.6, but we've not changed anything in 11.5.7, 8, and in the future version, which is 11.5.9. So this documentation is the same for all versions subsequent to 11.5.6. So if you look at this documentation, you follow the steps there, and it's very easy to try this on a test system. And I'll show you what you need to enable. And you try it on your data, and if you have any feedback, I would love to hear that. So here's how you enable the machine learning optimizer. You just do the Db2 set. So this is only for the tech preview, and I'll come to how we are planning to change it when we productize it. There is an extra step that's needed here, which is to create the model table where we store the model. This is stored in the systools directory. This is just for the tech preview. Eventually, in the productized version, we will have it in the catalogs, but since we were not allowed to define a new catalog we are only allowed to define a new catalog on the version boundary, we decided to use the systools user table. We need auto run stats because that's how we do the automatic collection and training of the model. So we need this on. In the tech preview, we do have some facility where you can use run stats itself, but I don't recommend trying that because that's something that we are looking at avoiding even in the GA version. And to disable the optimizer, you just need to turn it off and it will drop the models automatically. If you want to compare it with the traditional optimizer, you can temporarily set it off. The models will still be there, but you can see how the traditional optimizer does and compare the estimates to what you see in the explain with the machine learning enabled. So what do we cover in terms of the predicate types? And we do equality predicates, we do in predicates, we do between predicates, range predicates, and or predicates. So, oops, I think I have to go back. And this is all the local predicates that we handle. What we don't handle is, for example, parameter markers, and we don't handle expressions on columns. This is something that we are hoping to do in a future version. We also have a very limited version of join predicate cardinality estimation. So what we decided is, since we are building a model for each table that you have, and you enable the machine learning optimizer for, we use that single table model on 2 tables to come up with a better estimate than we have today. It's not completely accurate in the tech preview, but that's kind of what we are improving. And we've got a good prototype at the moment, which is not in the tech preview, to help us with joint predicates. Okay, so I said pairwise joint predicates, and that's a term that you might hear me use. So how do we do this? Like I mentioned, we use the same infrastructure that we have for the auto run stats, and we extend it to do the auto training as well. So essentially, if there is a table without a model and the auto run stats says, we should be collecting a model on this, the first step that we do is a discovery step. And this essentially tries to find the most correlated columns to define the model on. And the only reason that we do this is, if you have a table with 150 columns, it's going to take a long time for us to build the model with all combinations of predicates across various combinations of columns. And that will take time. So we're just focusing on the ones that we think our current traditional optimizer will struggle with, and we just take the top 10 in the tech preview. In our productized version, we will increase that to 20. At the same time, we also collect a sample of data. It's a small sample, but it's enough for us to get an idea of the estimate of the selectivity based on the sample size itself. We also use the sample data to generate queries automatically. And here we generate 500,000 to 1 million queries. And that's what we use to train the model, like I showed you with that neural net diagram. Once we build the model, we store it in the systools table in the tech preview. Eventually, we will have a separate catalog, and that's what we will use to store the models. Okay. So in terms of using the model, it's kind of similar. When a query comes in, it goes to the optimizer. The optimizer looks at what models are defined. If the table has a model and it covers the columns in a set of predicates used in the query, it will take those predicates, encode the predicates as input into the model, and the model will give us the selectivity prediction. And that we will use in the optimizer. If there are any predicates that are not currently handled by the model, the traditional optimizer will compensate for that and use what it does today. And with that, we build a plan and send the execution code to run the query. In terms of feedback, the tech preview does not have any query, the optimizer or runtime feedback. What it does is it uses the same infrastructure today that we have for statistics, which is if the table has changed sufficiently, we will automatically trigger the retraining. So now you might say, with 500,000 to 1 million queries that are used to train the model, it's going to take a long time. And what is the model size? So initially, when we started, the first prototype was using a neural net. We asked the experts, what algorithm shall we use? And they suggested XGBoost and LGBM, which is a gradient boosting algorithm from Microsoft. It's open source, and we tried to use it because it was written in C++. Most of the models are written in Python, and to embed that in Db2 is something that posed a problem. But with the LGBM model, we did some tests, and we found that the model size was massive. It was 33 megabytes per table. Also, the training time was around 5 minutes. And we said that's not going to fly. So we had this neural net model that one of our students wrote as an exercise, and it was brilliant because it gave us almost as accurate results as these gradient boosting algorithms. But also, in terms of the model size, it was just around 20 to 30 kilobytes compared to 30 megabytes. And in terms of training time also, we found that we could get to within 2 minutes on average, 1 to 2 minutes. So that was our goal. We said we're not going to sacrifice anything in terms of training time. We want to restrict it to under 2 minutes, and let's see what we can do with that. In terms of testing, we tried this on some, real-world customer performance issues that were reported, and we simulated that in-house, and we tried it against, the traditional optimizer versus using the machine learning. And we were quite thrilled to see that we did very well. And one of the key reasons for us doing very well for some of those queries was today, even if you have column group statistics, we don't use column group statistics to detect correlation between predicates or range predicates, or a range predicate and an equality predicate. And that's where the traditional optimizer was underestimating it very significantly and giving us a suboptimal plan. Whereas with the machine learning optimizer, it was well suited for detecting these correlated columns within the neural net model, because that's what the neural net does. It takes a set of data and it looks at relationships between the columns, and it tries to capture that using the weights on the edges between the nodes of the neural net. So that's where we can benefit significantly from using the machine learning model. So some query patterns are like this, like I mentioned, between predicates. Also, so if you look at the first example, we are trying to find out all the people who stayed during the Christmas week of these different years, 2017, 18, and 19. With our default estimates in the traditional optimizer, we found that about 90% of the people who stayed in the hotel in those 3 years were estimated as staying during the Christmas week, which was not realistic. Similarly, correlation between range predicates and equality predicates. So this is where we will get much better results. In terms of joint cardinality, you can see here that I'll first explain what these diagrams mean. So there are two plots, box plots. Let's look at the one on the left. So you can see that there are 3 box plots here. The one on the right-hand side, which is the one in this mustard color, you can see that the center of the plot is below 0. If it is at 0, what it means is that the estimate value is the same as the actual cardinality. So the closer to 0, the better it is. If this box is very wide, what it means is that we're all over the place. Our estimates are sometimes close to 0, but sometimes pretty far from 0. And we have a lot of these outliers which are way, way underestimated. So these are on combinations of predicates. This is using the default statistics, the one in mustard color. The one in gray color is after we define the relevant column group statistics. This is what we got. But we are still quite wide, and we are still further or closer to 0, but not quite there. And we have a lot of outliers. So again, the estimates for range predicates and combinations of range and equality predicates were underestimated, even in spite of having column group statistics. With the machine learning model, you can see it's very compact. So the estimates are very reliable, fairly stable. It's close to 0, which means it's close to the actual cardinality. So that's the power of machine learning. The box on the plot on the right-hand side is very similar. This just has multiple joint predicates. And here you can see when we have multiple joint predicates, it's even worse. We are far from the actuals, both with the default statistics as well as with column group statistics. And here we have a slight overestimation, but it's still close to 0 and it's fairly compact. So in terms of plan for production, we are focusing on a few things. Infrastructure is one of the key areas. We are making it solid. We've got new catalogs that we would ship on a version boundary. So whenever the new version is scheduled for, that's when we will ship the new catalogs. We've solidified it in terms of security and access control. In terms of audit, all the operations that are in the background will be recorded. We are also doing a lot of usability enhancements. Explain support is one of them. We have very limited support in the tech preview, so you can see the estimates, but it doesn't give any further guidance in terms of explainability in some sense. We're going to do the activity logging, so all the auto training that is done will be logged. We're doing better model management where you can do things like rename of the model and dropping a model and things like that. We're going to replace those registry variables to enable and disable by changing the configuration management, and I'll show you what we're doing there. Handling error messages, some DDL to manage the models, and any kind of dependency management. So if you drop a table, you need to drop the model, things like that, the normal things that we need to do. We're also doing and have done so far many model enhancements. So we've improved the model size, as I mentioned, from to something relatively small. We've increased the number of columns that we're handling compared to the tech preview. And our goal was to keep it within 1 to 2 minutes of training time. So we optimized the code and the model so that we can still keep it in 1 to 2 minutes and double the number of columns that we handle. And keep the model size the same. In terms of configuration, these are the 3 things that we need to worry about. notice that automatic AI maintenance is a separate thing. It's not under automatic run stats. Maybe I'll put my pointer. It's not under the options for automatic run stats. It's a separate entity under automatic maintenance. And this is key, setting the maintenance to on and the machine learning optimizer to on. We also want to set discovery to on as well. These three need to be set to on. But because it is done as part of the auto run stats, eventually we're thinking of separating it, but at the moment you need auto run stats to be on as well. Okay, so that's in a nutshell what we're doing. We're very excited with this project, and we've got a few papers out right now. We've got lots of patents in this area because we were one of the early starters. In 2013, our paper must have been one of the first papers on application to the optimizer. We've got a paper on joint cardinality estimation as well. We've got many patents in the pipeline related to this, and we are really thrilled about this whole feature. With that, I think I'm done. So thank you.
I've got a question here for you, Calisto.
Sure.
The question's from Francis, and it says, can I use the machine learning optimizer on nickname objects, or is it only for DB2 tables?
Very good question. We're using it currently only for DB2 tables, and this is something that we are considering for future. As you know, one of our big strategic goals is to get DB2 integrated with the Lakehouse. And for that, we will be looking at external tables and nicknames. So it's something that we will do as a priority eventually because of Lakehouse.
Great, thank you. Here's another question from Brian. Does DB2Z have a similar AI infusion into the DB2Z optimizer?
Not similar. I know that they have some aspects. For example, they do handle some learning with respect to parameter markers. I think for us in the warehouse space, we were seeing a lot of issues with respect to cardinality estimation and these complex queries. So we didn't focus on parameter markers as much because we wanted to address the bulk of the performance issues that we saw. In terms of future capabilities, I'm not exactly sure what the plan is in terms of, I know that DB2Z, they looked at doing machine learning for costing, so they would cost the various operators. But I also know that when they did the testing, they were very, very reluctant to let it loose because I think regressions on the mainframe are frowned down. They don't want to see regressions at all, and I think that was one of the reasons that they kind of backed off a little bit. But in terms of reviving that effort and looking at other aspects, I'm sure that they will look at machine learning. Yes,
regressions on the mainframe have always been frowned upon. I speak from experience there, yeah. And is the machine learning optimizer infused for the DB2 or used for the DB2 Blue feature on column tables?
Yeah, it's not restricted to column tables. We can use machine learning for any table, row or column.
Okay, good to know. Okay, I'm just giving people one last minute to write up any questions. Let me, while we do that, I'll take back control because I need to do the final polling question and also to show our screen. So now I'm presenting. Oops, I need to click this button and now I'm presenting. So, and we have one more question in from Francis. Is this available for Watson query?
We want to open it up for all form factors of DB2. It's not going to be restricted in any way. So, I mean, again, if it is in the federated environment, right now it's not the model to handle that, but we will look at nicknames and other tables, external tables.
Well, based on the questions I'm seeing, people have certainly learned an awful lot. Here's another one for Hadoop external tables. I think people are coming up with other possibilities for you.
Yeah, that is going to be a priority. It's something that we'll look at as soon as we finish what we intended to as our MVP for the GA.
Yeah. Okay. I think we'll cut the questions there, and let me move on and show our last screen here, which is our thanks for coming screen, and the last bit of notification on the DBI tools. And with that, I'll launch our last question for today, which is always, did you learn anything? We always hope to see that people learn something from the show, and I'm hardly surprised that what we're seeing right now is that 100% of our audience learned something, which is absolutely what we like to see people say. And I'm really not surprised. There was a lot of great information in your presentation. Hopefully people have a better idea of what the machine learning optimizer now does and how they can use it. And it was great information. So thank you so much, Calisto, for coming on and sharing your knowledge with us. And we appreciate the information.
Thank you, Matt. Thank you all.
And for all people around the world, please enjoy, if you're in the Northern Hemisphere, please enjoy the first weekend of summer, starting now. And we will see you again on the Db2 Night Show. But this is it for this season. Enjoy your summer, and we'll see how the fall shakes out next year. All the best to everyone.
Thank you. And if you'll get a chance to test out the tech preview, I'd love to hear your feedback. So
and also, Calisto, if you could send your slide deck along, I'm sure people would love to have that to view as they watch the replay of the show.
I will as soon as we finish.
Thanks so much. All right, here comes the music. And once again, let me pass on my thanks. Thanks for watching. Thanks to Calisto. Thanks, Calisto, for presenting. And that does us for this show. All the best, and thanks so much. Bye-bye.